All right, so we're now moving on to section 2G, and we are going to be dealing with parallel and perpendicular lines. So our objective or our goal for today is you will now know how to write the equations of lines given that they're parallel or perpendicular to each other. So we're going to have to be able to identify what it means to be parallel and perpendicular and use that information to then write the equation of a line. All right, so let's go ahead and talk about parallel and perpendicular lines again real quick, and then we'll get into a couple examples. So, as we talked about in class before, and we kind of solved for this, we know that parallel lines, one, they're two lines that never intersect, so it means they never ever touch. And we can identify that they're parallel because they will have the same slope. So if the two lines are parallel, then we know that their slopes are exactly the same. So if we look here, these blue lines and red lines, they will never ever touch. They're parallel. And if you notice, they both have the slope of 1/2. So if we're told that two lines are parallel, we know that they have the same slope. So if I say that y is equal to 5x plus 2, and I tell you that there's another line that's parallel to it, identify its slope, well, we know that this new line slope would also have to be 5 in order for it to be parallel and never ever touch. All right. And as we talked about before with perpendicular lines, there are two lines that intersect, but they intersect to form a right angle, meaning 90 degrees. And we know that if we multiply their two slopes together, then we get a product of -1. So if we look here, they tell us that these two lines are perpendicular because they give us this red box, which we know means 90 degrees. And if we look, we see that we have a slope of -2 and positive 1/2. And -2 times 1/2 does equal -1. So we know that they are perpendicular. And one of the things that we also talked about in class was we can say that they're negative reciprocals of each other. So if I give you 2/3 and I ask you to find the slope that is perpendicular to that, well, we know we can first take the reciprocal. Remember, you say you love me, but now you flip them like reciprocals. So we can then rewrite it as 3/2. And then we take the negative of it, meaning that if it was positive, it becomes negative. If it was negative, it becomes positive. One of the things that we have to remember and that we discussed as well is that undefined slopes and zero slopes are perpendicular because vertical lines and horizontal lines will form a 90-degree angle. And if it's undefined, that means that we're dividing some number by zero, and we can't, which is why it's undefined. So then when we take its reciprocal, it becomes 0 over some number, which we know is equal to 0. All right, so remember, if I give you an equation, y is equal to -1/3 x plus 4, and I ask you to find the slope of a line that is perpendicular to that, well, first we will take its reciprocal. So the reciprocal of -1/3 is going to be 3/1, and then we take the negative of it, so the opposite sign. So that means that this slope will be equal to a positive 3/1. All right, so those are some key ideas that you have to be able to remember and recall when we're answering some of these questions. All right, so let's go ahead and start answering some of these questions. All right, so this question says, write an equation of a line that passes through a point, 6, -2. So the line that we're creating must pass through that point and is parallel to the line y is equal to 1/2 x plus 3. All right, so remember, when we're solving this, we're eventually going to want to rewrite it in our slope-intercept form. So y is equal to mx plus b. We need to solve for our m and we need to solve for our b. Well, since they tell us it's parallel to this equation, that means that they have to have the same slope. So if this line has a slope of 1/2, that means our equation must also have a slope of 1/2. So I can already go ahead and start solving and say that the equation of my line is y is equal to 1/2 x plus b. All right, now we need to go ahead and solve for what our y-intercept is, and we can use the point that our line passes through. I'm using the slope-intercept form for this one. If you prefer to rewrite it in point-slope form and then rewrite it in slope-intercept, you can go ahead and do that right now. But we know that this is a coordinate of x, y, so that means x is equal to 6 and y is equal to -2. So we can go ahead and plug that in. -2 is equal to 1/2 times 6 plus b. And now that we're down to one variable, one unknown, we can go ahead and solve. Well, 1/2 of 6 is 3, so -2 is equal to 3 plus b. And I'm going to go ahead and subtract a 3 from both sides to solve and isolate my b, which is then equal to -5. So then my equation, y is equal to 1/2 x minus 5. So this equation is parallel to the given line here and will pass through the point of 6, -2. All right, so let's go ahead and move on to our next question. All right, so this one is a little bit more challenging because they don't give us the equation of the line like the last one, but we do know it's going to be perpendicular. So it says write an equation of a line that passes through the points of negative 3, 1, so it has to pass through these points, and is perpendicular to the line given in this graph. So they don't flat out tell us the slope of this, but we can solve it one of two ways. And the two ways we can solve it is we look and see, well, where does this graph cross the corner of our box? And the reason why we look at that is because it means it's crossing at a whole number. And we can either do one of two things. We know it's change in y over change in x, so we can count down 1, 2, 3, 4. And then I can count over, so my change in y went down 4, so that means it was equal to negative 4. And then my change in x is to the right 1, so it's positive 1. So I can see that it's equal to negative 4. All right, so that's how we can find our slope by just counting it. Or we could have picked these points, and we can see that this has a y-intercept of 5, so it's a point 0, 5. And here we have a point of 1, 1. And we could have then go ahead and said this is x1, y1, x2, y2. We could have plugged it into our slope formula, so we could do 1 minus 5 over 1 minus 0, which is negative 4 over 1, which gave us the exact same slope. Doesn't matter which way you do it. All right, but now, since we know that this slope is going to be perpendicular, well, the slope is perpendicular to this, we need to take its reciprocal, so we will flip it and get 1 over 4, and then we're taking the negative of it. So since it was negative, that means that this is going to be positive. So in my equation right now, I can say y is equal to, remember we're solving for mx plus b. So right now we already solved for m. It's equal to 1/4 because the only way that it can be perpendicular to this blue line given is if it has a slope of 1 over 4. So now I know that y is equal to 1 over 4x plus b. So the last thing I have to do now is solve for this b. And we know it passes through the points of negative 3, 1. And since that represents an xy, I can say that my x is equal to negative 3 and my y is equal to 1. So I can go ahead and plug it in. 1 is equal to 1/4 times negative 3 plus b. All right, so then from here, we'll multiply and get 1 is equal to negative 3 over 4 plus b. So I'm going to add over my 3 over 4, add over 3 over 4, and I'm going to do the work over here. We can do 1 plus 3 over 4. So we're going to multiply this by 4 over 4 so we can get our like denominator. So 4 over 4 plus 3 over 4 is then equal to 7 over 4. So our b is equal to 7 over 4, which then means our final answer is going to be y is equal to 1 over 4x plus 7 over 4, and that will be our final answer. All right, now there's just one more question that we're going to go through, and we're done with this video. All right, so this last one we're going to do is find the equation of a line that passes through the point 5, 2, and is perpendicular to the equation y is equal to 3. So right away we need to identify, okay, well, what does the graph of an equation y is equal to 3 look like? And what you should know by now is that this is going to be a horizontal line where y is equal to 3. And remember, in a horizontal line, we have a slope that is equal to 0. So now we're going to look for our line that's perpendicular to it. So since it's a horizontal line that we have here, that means the only one that's going to be perpendicular to it is a vertical line, right? And a vertical line will have the opposite slope. So remember, since this was 0, that means that we were doing 0 divided by some number. Well, then when we take its reciprocal, it becomes n over 0, which then means it is undefined. And in an undefined line, we know it is vertical, which then means x is equal to is our equation. So all we have to do in this case then is look at the point it's passing through, which is 5. And since x must be equal to 5 in order for it to pass through, this is an equation of x is equal to 5. Right, so in some of these cases, it could be a little bit more challenging when we do this have these one variables is equal to, like y is 3 and x is 5, when we have these horizontal and vertical lines, because then we have to be able to identify exactly what is parallel, what is perpendicular, and we can do that through quick sketches like I did here. I didn't really plot this accurately, I was just making a quick sketch, or we can kind of think about this and just know that when we have y is equal to, if it's going to be perpendicular, that means x is going to be equal to as well. All right, so there's different ways that we can go about doing this, and we'll be practicing these problems throughout the next couple days.